This video shows how to use a double number line strategy with standard 7EE4, which states use variables to represent quantities to solve real-world or mathematical problems. Specifically, we're going to focus on Part A, fluently solving multi-step equations with a variable on one side. When taking a look at the unpacking guide, you will see that in 7th grade, students move from the arithmetic approach to develop an algebraic approach to solve equations and inequalities. Students describe the relationship between both approaches, paying particular attention to the sequence of steps.
Students should understand that a double number line shows equivalence. In this example, we notice that x is equivalent to 12. If we move to the right on the number line, we see x plus 1. We get that from adding 1 to x. So we must also add 1 to 12. So 12 plus 1 is 13. So x plus 1 is equivalent to 13. Likewise, if we go over here to the number line, we have x minus 5. We've gotten that from subtracting 5 from x. So we must subtract 5 from 12 to find the equivalent number. So 12 minus 5 is 7. X minus 5 is equivalent to 7. In this next example, students should notice that 2x minus 3 is equivalent to 5. To solve this problem, we can find what 2x is equal to by moving 3 units to the right. Since we need to keep the expressions balanced, we move 3 units to the right on the bottom number line as well. 5 plus 3 is 8. So 2x is equivalent to 8. 2x means there are 2 groups that are equal to 8. If 2 groups are equal to 8, then one group is equal to 4. Students get that answer by dividing by 2. Again, on both number lines. So x is equivalent to 4. Let's take our visual approach and let's move it to an abstract approach by solving algebraically. We have 2x minus 3 equals 5. The first step we did on the number line was added 3 to both number lines. So we will add 3 to both sides of our equation, keeping it balanced. Noticing that minus 3 plus 3 are a zero pair or inverse operations, so they cancel. So 2x is equivalent or equal to 8. Then we divided by 2 on both number lines. Again, seeing an inverse operation. So x is equal to 4. In our final example, we have 1/2 times the quantity of x plus 4 is equivalent to 6. Half of this group is 6. So the whole group would be equal to 12. Students recognize this by multiplying both number line numbers by 2. Students should also recognize that one group of x plus 4 is the same as just saying x plus 4. To solve for x, we are 4 places too far to the right, so we have to back up 4 places by subtracting 4, and that leaves us with x. We must do the exact same thing on the bottom number line. So if we back up 4 places, 12 minus 4 is 8. So x is equivalent to 8. Again, let's match what we did on our visual approach of the number lines, and let's move to the abstract approach by solving algebraically. 1/2 times the quantity of x plus 4 is equal to 6. The first thing we did was multiply by 2, so we must multiply by 2 on both sides of the equation. Students should recognize that this is a multiplicative inverse. So we end up with 1 times the quantity of x plus 4 is equal to 12, which is the same as x plus 4 equals 12. Then we have to subtract 4 from both sides, keeping our balance of our equation. Again, noticing the inverse operation here. So x is equivalent to 8.
To summarize, this video showed how to use a double number line strategy when covering 7EE4, fluently solve multi-step equations with the variable on one side. To show the vertical progression, we should back up to 6EE7. In 6th grade, students were solving real-world and mathematical problems by solving one-step equations with non-negative rational numbers. Later in 7th grade, students will take what they learned in 7EE4 and apply it in 7G5, where they take facts about supplementary and complementary angles to write and solve equations for the unknown angle in the figure. And finally, in 8th grade, they will solve real-world and mathematical problems by writing and solving equations and inequalities with the same variable on both sides.